Hello, everybody, and welcome to another episode of Bitcoin Core PR Review Club. And today we will be taking a look at PR number 18267, which is quite a old PR. Got merged around end of 2020, and this PR adds the Signet support to Bitcoin Core, and we will go deeper into what a signet is in its design, how it's different for different kind of networks, like testnet and mainnet. And so let's just dive in. um, to start with, we'll have a basic discussion about Signet, what is a Signet, and how it is different from a testnet. So let's start with the idea of testnet in general. What is a testing network? In Bitcoin and in many other kind of like cryptocurrency network, generally for development purpose, the developers prefer to use some dummy network or some toy network which does not have the real unit of account, because in order to create transactions, in order to do experimentations, you need to have coins, and there can be situations where things can go wrong and you can lose those coins. So for that purpose, testnet and different kind of testnets are designed. And testnets are basically, as the name suggests, there's a network for testing which tries to mimic the existing bitcoin main network and has coins which does not have any value. So these coins can be like freely acquired for testing purpose and all. So Bitcoin previously already had a testing network. It called the Bitcoin testnet, and later on it was discovered that various problems were there around the Bitcoin testnet. Because of this kind of problems, the reliability of block production of testnet was quite difficult, because in mainnet we are habituated with like 10 minutes on average block intervals, and very seldom there are like 2 to 3 block reorgs happening once or twice per month. In testnet, the block production interval could be varying massively, from 10 blocks in 10 minutes to no blocks in 2 3 hours. And this kind of creates difficulty for developers who are trying to use testnet to simulate mainnet kind of behavior for their testing purpose. For example, they want to test different kind of lightning network proposals and different kind of lightning network channel open and closing scenarios where block reward and block intervals plays a major role. To address all this kind of problem, a new kind of test network was proposed in BIP-325 called Signet. And the main difference between testnet and Signet is Signet blocks requires an extra signature validation apart from proof of work validation, which is not there in either Bitcoin mainnet or Bitcoin testnet. So in a sense, Signet is kind of like permissioned, where there are like set of delegated block producers who are the signatories of the new blocks. As the Bitcoin wiki defines, a proposed new test framework for Bitcoin blockchain which adds additional signature requirement to block validation. And this pull request basically implements a part of BIP-325, which is responsible for block validation as we start our node in a signet mode for validating the new blocks. So that's the main difference between testnet and signet. So we start with our first question of like, why do we need a test network and what the problem do we have with the current test network? So the current test network has this problem of being unreliable, where block production and large reorgs are block productions are very haphazard and large reorgs are very frequent. So to address all this problem, BIP-325 proposes a new kind of like testing network which are called Signet, which apart from proof of work also requires a signature validation requirement. Before we go into the details of the rest of the PR and go jump into the question, let's just quickly go through the BIP-325 and look at the Signet application, Signet design, because there is a certain specific things to be noted about Signet, which are very different than the rest of the network's block production. So BIP-325 defines the motivation and the idea behind having a signet, and what we just discussed in the first part is described in the motivation section of this chapter. And in the specification, we will see that the signature verification for signet blocks happens in a very curious manner. And this section starts off with this description. To sign a block or verify a block signature, two virtual transactions, each with a single input and output, are constructed from the block as follows. The two spend transaction that looks like this, and then a two sign transaction that spends the two spend transaction, and the two sign transaction looks like this. And the curious part is, like, instead of like directly using signature verification against a particular pub key, the signet designer used like the signet designer leverage the existing transaction verification mechanism. And because transaction verification already contains a signature verification inside them, so it creates two hypothetical transactions called to spend and to sign. And by verifying the two sign transaction, if the two sign transaction passes the consensus verification of Bitcoin core, that means the signature of that block is valid. And how does that work? So the two spend transaction looks like this, and the script sig of the two send transaction contains the block data. So in a way, the two spend transaction has a commitment to the block data. So the two spend transaction data itself contains the block data inside the script sig, and the script pub key is called a signet challenge. We'll talk about signet challenge in more details later on, but think about signet challenge as any kind of like p2pkh public key, or any kind of public key, script pub key, that we see in regular transaction. And to sign transaction looks like this, which points to the to spend transaction previous tx id and the previous output index, which is 0, because the to spend transaction only has one output. So it points to the to spend transaction, and it provides a script sig and the script witness. This script sig and the script witness, the data inside these two fields, comes from the Coinbase transaction of the Signet block, which is created by the miner of Signet. So the miner of the Signet, inside the Coinbase transaction, somewhere they will provide some data which represents a script sig and script witness, which is valid for this Signet challenge. So just like any other transaction verification, we have the script pub key, we have the script sig, and we have the script witness. Um, just like any other transaction verification, we have the script pub key, we have the script sig, and the script witness. So we concatenate the script pub key with the script witness, execute the whole script, and if it's valid, then we say like the transaction is valid by signature. So just like any other transaction, the these two virtual transactions will be created at the time of verifying a signet block, and these datas are calculated from the block data itself. So this is the signet block data, and these signatures and witness are extracted from the information included in the Coinbase transaction. And if the signature is right, that means the block has been produced by the correct signatory, then to sign transaction will be valid by the verification mechanism of Bitcoin transactions. And when to sign transaction is valid, we know the signet block is valid. So this is one interesting point about how signature verification is done inside Signet, along with the proof of work verification that is there. And this allows the mining to be centralized. And because the mining is centralized, so the So the block production and the simulation of the test network can be replicated to be very close to the main network situation. And that's the main value proposition of Signet. So with that, we cover the basic idea of what a Signet is, what was the problem of testnet, and how Signet blocks are verified according to BIP-325 very curiously by creating two virtual transactions. By the way, these are not real transactions and they don't exist in the Bitcoin blockchain. They are created solely for the purpose of verifying the signature of the block of signature of the Signet block. So with that, let us move ahead to the next question. What are some parameters that distinguishes mainnet, testnet, and Signet? Which of these do the different network have in common? What makes Signet special? So to answer this question, now we will delve down into the code base and see how different networks and different parameters for different networks are defined in the Bitcoin core code base. So here in consensus chain parameters.h, we have this class called chain parameters, and chain parameters have a lot of members, that is like gets different kind of chain state, different kind of data, and it also has some values, and these values together defines a particular chain. So for mainnet we will have different values, for testnet we will have different values, and for Signet we will have different values. So the first part of the first data that it contains is consensus parameters, and this parameters contains all the various parameters. Let's take a look at the parameters. This is defined in source parameters.h. Sorry, source consensus. Yeah, we'll discuss about rec test also in contrast. And so this parameters.h is inside consensus module. Consensus module has bunch of other things, and it also has a thing called parameter.h. And so chain parameter.h um, has chain params has a first value called consensus params, which defines all the parameters that for a particular chain. So let's look at how the main chain looks like. So main chain has this kind of stuffs. It has certain these are like the consensus parameters that is defined in params.h, and these are like different heights where different soft forks got activated, and together all this data defines what a main chain is, right? And then we have the genesis block of the main chain, we have the hash of the genesis block of the main chain. So if each network, each chain in that sense will have their own genesis block also. So then we have some seeds where the initial DNS lookup for connecting to peers will be done inside these parameters. Then we have some checkpoint data. So these are historically known blocks which are deep inside the Bitcoin mainnet, and these are used in the process of IBD. While the block is, your node is syncing the block, it will check at certain height whether it's matching with the known main chain block of that height. So similarly, there is a testnet parameters, define certain things about the testnet. Then there is the Signet parameter, and this Signet parameter was added inside inside this PR. And there are like many different things that are happening inside the Signet parameter. Then also the consensus Signet thing, consensus values are being created. So here in the first part you can see like consensus Signet blocks equals to true. This value is only kept true for only the Signet network. For other things it's false. For testnet this is false, for mainnet it is all false, for rec test also this is false. And the height for different soft forks are all kept one. So at the very first block all the soft forks are activated. So and yeah, so this is how inside chain parameters we define a particular network for Signet, mainnet, testnet, and rec test. And as MK asked, how does the rec test look like? So here's the rec test. So it also like similar signet chain parameter, consensus parameters are defined. We have some activation height for different soft forks, 65, 66, CXV, BIP-34. This is different from mainnet though, but it's not one. Unlike Signet, it is defined for certain things. There are some reasons why they are different as defined as certain values instead of one. And and this is how the rec test parameters look like. So anybody gives a summary of what a rec test is?
Well, Rectest is a kind of private blockchain which runs on a local system, and it is
Yes.
not like connected to globally like testnet or something. But at the same time, uh, it does the work of what Bitcoin does. Bitcoin blockchain does.
Right. Yeah. So the
Mm.
rec test is something that you can like spawn up very quickly. You are your own block producer, right? So you can create your own block. You can invalidate the block. You can like do whatever you want. So it's like kind of like you can create two different rec test node inside your local machine and connect them together, and then you have your own little Bitcoin network running inside your local machine. And a lot of the functional tests we will see also, like we'll look into a functional test where we are testing some signet stuffs, um, are like using this kind of setup where three four different rec test node are spawned, they're connected with each other, and a laboratory bitcoin network is simulated inside the local machine. So this is also useful for various kind of testing, but it's not at all like the real network, right? Because you will manually have to create the blocks there. So yeah, so this is what these different parameters looks like, and this different parameters kind of cumulatively defines all the different kind of bitcoin networks that we have. Okay, so that defines what are some parameters of distinguishes mainnet, testnet, and signet. Which of these do the different network have in common, and what makes signet special? So basically, all these consensus parameters are the things that are common. Maybe the values are different, but the parameters are common. And the only way signet is different is like it has a signet block equals to true defined inside consensus for signet, whereas signet block equals to false is defined everywhere else. So in signet case we'll see signet equals to true. At the same time, it also has a thing called binary. And as we go along, or if you look deeper, this guy is what we have been talking about as the Signet challenge script. So this is a script pubkey that was Signet challenge, which was solved by the signature that was created by the block producer. And this Signet challenge for the default Signet is this guy. And anybody wanna take a guess what this is a script, this is a bitcoin script, what this script might be? Maybe by looking at the first this portion. Okay, so we'll do another thing. So um we'll later on like we'll see how this is the script that is like put inside the script pub key of that transaction, that virtual transaction of transaction to spend. So there is a nice little tool in bitcoin cli called bitcoin cli. So I have a signet running over here. So this is a signet that is going on, and we are at signet. This is the default signet, and we are at height 1480. So Bitcoin CLI, there is a method called decode script, and if we just give this value to this guy, so it decodes the script and tells us what this script is all about. So this is a multi-sig with this is one pub key, and this is another pub key, and this is a one of two multisig, and these pub keys are the two pub keys of two signatories of Signet. At the time of, like, I'm checking it out at the time of, like, the PR was merged, so it was Calais and AJ Towns. They are the two signatories of Signet, and these are the pub keys of two of them, and any one of them can create a valid signature, right? So among the two of the signatories, it's a one of two multisig script, and any one of them can create a valid signature that can go inside the script sig of the two sign virtual transaction, and that's how the signet block will be validated. So this is also defined as a part of this binary, and this binary is going inside this signet challenge. So consensus has a parameter called signet challenge. So sorry, signet block and signet challenge. These are the two things that are not defined for any other network. Only for Signet these are defined. So signet challenge is basically assigning the entire binary, like this entire hex in binary format is the signet challenge. Any question so far? Okay, so let's move ahead. Let's move on to the next question. How many signets are there? Could we start our own just for the review club? And if so, how we can do it? Anybody have a guess? So this is another difference between Signet and Testnet. There can be like, different signets, and there can be multiple signets going on at the same time. In fact, we will see two kind of signets in next. But anybody have known about other signets apart from the default signet? So yeah, so signets can be defined, like we can create our own signet and we can be our own signet signatory. All we have to do is like define this challenge script, and this challenge script is for the global default signet. That is the default signet that is running when you put Bitcoin D signet equals to 1. But there is a parameters. There is a parameter. The parameters are defined in. Let me check. Hmm. I can't seem to identify which file had the parameter. Let's try to look at the files changed in the PR. And not the make file. Chain based parameters, yes. So chain based parameters.cpp. So chain based parameters.cpp is another file where certain arguments are defined. So these are the arguments that you give after typing Bitcoin D. When you are starting Bitcoin D, you can say like start Bitcoin D in testnet, start Bitcoin D in rectest, start Bitcoin D in any other kind of chain. And for Signet, these three parameters are defined. So you can define Signet. This will go to the default Signet challenge. The default Signet challenge will be the global Signet challenge that is defined in the code base. But you can specify your own Signet challenge. And if we create our own signet blocks, we come up with like three of us come up with like a two of three multisig for signet challenge, and any two of us can sign for transaction in those two of three. So that's our own custom signet. So in that way, people can also create their own custom signet network. And then we can like tell other people like, hey, add our node's address into your parameters. So your node, while connecting to the network, will connect to our node. And that's how you become part of our own little toy signet network. So that's how signets are customizable. So signet is kind of like customizable in terms of like you can create your own policies. And right now, as far as I know, there are two signets going on. And luckily, they both have a mempool explorer. So mempool.space has the Bitcoin mainnet, Signet, and testnet. So if you go to Signet, it will look at the Signet blocks that are going on. You can see Signet blocks are typically very empty, like it only have one or two transactions, and people are using this transaction for testing purpose and stuffs. And these are, let's refresh the page and see what's the status. Yeah, so this is the current state, like it's at height 248148435. Does it make sense? It our thing, no, it's saying our height is at 148048, and mempool signet is 1848435. I don't know why that's the case, but anyway. So this is the mempool's like default signet, that is like AJ Towns and Calais for like managing. And then recently, Mutiny Network, this is a Mutiny wallet, they launched their own custom signet. So this is called a Mutiny Net. And by to how to connect to the Mutiny Net, we have to just add those parameters. So this is the signet challenge for Mutiny Net, kind of like same, but it's instead of a two of two, let's try to do this and see what does the Mutiny Net Signet challenge script look like. So we have this, and we'll try to decode this. And it's a multisig one of one, which is weird because you could have like used a single, like you could have used a P2PKH instead of a multisig, because it's a one public key and a one of one multisig, which is essentially it's a pay to public key hash. And but for some reason they created an one of one multisig instead of a pay to public key hash. I don't know why they did it. Probably they just kept the script format same and just deleted one public key and added just deleted one public key and added one and made it at one of one check multisig. But they didn't need it to. They could have done a single sig P2PKH also. So that's an example of a custom signet. And that's how we add a custom signet into our Bitcoin core. So we specify what the signet challenge is. Using this signet challenge, the signet block will contain the signature corresponding to the signet challenge. Then this magic will happen. These two spent and two signed transactions will be created. And then with that particular signet challenge and the signature on the signet block, the validation will take place. And this is the node that we want to connect to, which the other node that is running this custom signet. And the signet block interval time here is 30 seconds. So this is, they also have a mempool, and you can see like the blocks are churning in the custom signet every 30 seconds. And they use it for their own testing purpose. In fact, anybody can use it for their own testing purpose. It's live and it's global and open to public. So this is an example of a Mutiny Net's custom signet.
So why did they do it? Is it just for the 30 seconds block time?
I guess so. Then they wanted to create a 30-second block time blockchain.
Oh, okay.
So they spawned their own custom signet for that.
And they made it public also.
They made it public
Nice.
also, yeah. So anybody can join and anybody can send transactions. So it's all about like it's as simple as like copy pasting these lines of code into your bitcoin.conf file and then restart bitcoin d, and your node will be connected to this custom signet. Okay, any other question on custom signets?
So if we wanted to start one for our review club, like
Mhm.
similar to that, we would just create a new Signet challenge
Yes,
and then assign a node for one of us will be a node and then
yes,
that should work.
yes. And then one of us has to run some mining
Ah,
script
yes.
where we are like creating the block and putting the correct signature corresponding to that challenge script into that block. And then we'll just publish this thing into maybe Twitter, and other people can connect to our custom signet.
Yes. Okay.
Cool stuffs. Yeah. So, what part of this PR affects consensus critical code for node running on mainnet? So, yeah, so this PR has been like a really big one. A lot of changes happened. And the consensus critical part, we can look from this whole change set. Um, so, there is like changes happening in chain parameters.cpp that we saw, like the signet chain parameters that got added. So this is very much consensus critical. And chain base parameters, these are some extra arguments that got added for signet challenge, so you can customize your signet challenge, signet and seed node, and all these things, so you can start a custom signet. um, I'm not sure whether chain params base is consensus critical, but I'm inclined to say that probably it is consensus critical too. Like if you do something wrong here, probably your node will crash and it will not work. And then consensus parameters dot h. This guy is definitely consensus critical. Um, this this param structures which defines different like activation height, and they added the signet blocks and signet challenge, which are only set to true and has a value for signet, and set to false by default for all other things. So this was definitely consensus critical. And validation.h, inside validation.h they added some extra code which was previously there in validation.cpp. They moved that code from validation.cpp and moved it into consensus modules validation.h. And so this is definitely consensus critical. Qt is not consensus critical. Signet.cpp, signet.h, this guy is defining, this whole function is defining what we just discussed over here, this two spend transaction and two sign transaction, right? And so this is probably not consensus critical because this is only useful for signet, and these functions are where, so check signet block solution, take a block, take consensus parameter and check everything is correct or not. This is where the final checking is happening. And you can see like here's the verify script that is going on. It's taking the script sig, it's taking the script pub key, it's taking the witness, some verification flag, and checking whether the transaction is being verified or not. We'll look into this part a bit more in detail later. So this guy are not consensus critical. And then there are changes happening validation.cpp. Validation.cpp is like the mothership of Bitcoin consensus. And if you look at this file, it's massive. It's the file that people don't want to touch the least, because this is where the entire Bitcoin validation engine is going on. And even if I just try to collapse it, it's just massive. It's just massive file with lots of function definition going on. the block validation, the transaction validation, difficulty adjustment, subsidy calculation, everything is going on inside. And the favorite part of this validation code is uh, subsidy, get block subsidy. This is like what makes Bitcoin. This is where the halvings are defined. Just these 5 lines of code is defining the halvings, the issuance schedule of the Bitcoin monetary policy basically. And it's amazing how simple this code is, depending on a height and some consensus parameters. From the consensus parameters, you are just taking the subsidy halving interval, which is, anybody can remember from top of their head, like what was the subsidy halving interval for Bitcoin?
Is it 2 years or
It's 4
something?
years.
4 years. Okay.
Yeah, so it's probably 21 210. mm, like it's 200 and how to say 210,000. So 2100, it's probably
2 lakhs.
210000.
So 2 lakhs 10,000.
I think probably some more zero like this, some number like this is the
So
subsidy halving interval.
so that's in line 1251. I see the same number.
1251.
Yeah, subsidy is cut in half every
Ah,
two
yeah,
lakh.
yeah, 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 yeah. This one. Every 210,000 blocks around 4 years, it's cut into half. And this is the halving that is making Bitcoin. And it's just 1 2 3 4 5 6 7 lines of code. Remove 2 comments, it's 5 lines of code. So all of this is going on in the validation.cpp. And so validation.cpp is this large ass file which defines the entire validation engine. And there are some changes that are happening in validation for CPP. For example, this function got removed from this guy and got defined into validation.h, consensus validation.h. So this is the validation.h in consensus module. This guy got defined over here. And so there are some changes that are happened in the validation part of the code. So after that, like, all the changes are not validation critical. So yeah, any other question on this part, like consensus critical code and validation and stuffs?
So how do we test a PR with like consensus critical code? I
So
assume it's very quick. Yeah.
yeah, so they added some functional test. So feature signet.py. This functional test basically is like, so first of all the other tests that are defined in the functional test. So if we look into the test functional folder, so this is where all the integration tests are defined. So test that the Bitcoin the Bitcoin node is working as expected. So all the other test has to pass, and they added extra test for the Signet part into this new Python file. And these functional tests are very easy to read. They're just Pythons, and very simple. And you can like even try to play around. Even like functional tests are the best place to start contributing into Bitcoin core. It's easy to understand, easy to contribute, and easy to write. So yeah, so it defines some hard coded Signet blocks and tries to, it creates 2 different nodes. It creates 6 node. We'll probably have it easier if we look into the Python file in the code. So it's in feature signet.py. Feature signet.py. So this is feature signet.py. So self number of nodes equals to 6. By this line, we basically say like spawn 6 rec test node and connect them with each other, right? And we can give extra argument for each node, right? And here you can see like different nodes are getting different Signet challenges. So here's one arguments 3, which is assigned to node number what? The 5th node. is getting assigned with args 3. The sixth node is getting assigned in args 3. So the fifth and sixth node are in this signet. Then args 2 is like the default challenge, like the default signet where the signet challenge is not defined. So the third and the fourth node are in the default signet, and then there is a signet challenge which is opt true. That means like it anybody can be a block producer. So the first node and the second node are in signet 2, this signet. So they are defining three different signets, six nodes. Each of the two pair of node are connected to each signets, and then they are like asserting certain conditionals.
Okay, okay. So it's like it's a signet like test basically.
Yeah, it's a
Yeah.
rec test. It's like signet inside your own local machine, with each signet has two node connected with each other. Quite
Okay,
cool.
okay.
And
Got it.
it's as
Yeah.
simple as this, of like creating and spawning a signet like that in rec test mode.
I
Not
have a
in rec
general
test mode,
question.
but in like, yeah, in Python file. Yeah, go ahead.
Actually, for running different nodes in our local system, do we need to create different bitcoin.conf files so that like every Bitcoin D can take its unique configuration and run other nodes? Because I guess we need to store
Yeah,
the RPC credentials.
I guess so. Like if you are doing like running it parallel manually, then you will need to define bitcoin.conf file for each of the different networks. Um, but if you are doing using this Python test framework, because it's using the Bitcoin test framework, you don't need to define the conf file. And in the Python test framework, you can like spawn nodes like simply without defining conf file. But if you want to do it manually, then yeah, you will need to define different data directories, and each data directory will have their own conf file, which are like defining the RPC node, the P2P node, and all these things.
Okay, okay.
Yeah. And if you are into different networks, so say you have two nodes which are like running into different networks, so one running signet 1, another running signet 2, the challenge script and the magic byte will be different. So uh I'm not sure whether the magic byte will be different, but yeah, the P2P port will be different for these two nodes, because then if you have the same P2P node shared between you, first of all, you cannot have the same P2P port shared between two process. When you spawn the second process, the process will say like the P2P node is already easy in use, so you have to define two different P2P node. Then you have to define two different RPC port, and all these different parameters. That's a good question. Yeah.
Well, thanks for answering.
Okay, let's move ahead. um so we kind of answered this. Okay, what new configuration option has been added? We also kind of answered this, and this is in chain base parameter.cpp. These are the three new configuration option that was added for signet. We can define a signet, we can define that run the node in a signet mode. We can define our custom signet challenge. If we don't define it, then the default signet challenge will be used. And we can define our own signet seed node. If we don't define it, then the default one will be used. Yeah, and these are the three parameters that has been used. So these are the configuration that has been added. We kind of answered this thing. What are the C transaction to spend, and transaction spending? Who broadcast this transaction? So we answered like this transaction to spend and transaction spending. Let's look into it in a bit detailed, where in signet.cpp this is happening, and this is happening inside the signet transactions create. So signet transactions is like a structure that has these two transaction. If we if we check, this transaction has this very simple structure, class called Signet transaction, which has a constructor, and it can create these two transaction to spend and transaction to sign, and will have a member whether it's valid or not. And this is defining this guy that are defined in the BIP, the to spend and the to sign transaction. And this is happening inside signet.cpp, inside this create function in the definition of create transaction. So to spend is defined, to spends values are being inputted, to spend is defined, to spend values are being inputted. um, some values are getting some values are being taken from the Signet block, and then the script sig is being populated with that particular value. So this v is coming from um, vector reader parser v into this Signet solution. Signet solution is coming from the Signet header and witness commitment. Witness commitment is coming from the modified Coinbase transaction of the block. Modified Coinbase transaction is coming from the block's very first transaction. So block's first transaction is the Coinbase transaction. We are taking the modified commitment transaction. From there we are getting the witness commitment. From there we are fetching the witness commitment into the Signet solution. This Signet solution is like finally what will go into the script sig, and then we are putting it into a vector reader. It's kind of like a C++ way of doing it. And then the transaction spending v input script sig is being populated with the Signet solution, and then the rest part of the thing is being populated in the script sig, the script witness part. And then basically we are just returning transaction to spend and transaction spending. And check Signet block solution basically takes a check block, a Signet block, take consensus parameters, and what it does here, it creates this Signet transaction, and it construct this Signet transaction from the block and the challenge script. So we have the challenge script, we have the block has the signatures embedded inside it. It creates the Signet transactions. And if m valid says like whether the parsing of the solution was valid or not. And this Signet transactions got created, and Signet transaction, then from this Signet transaction we just run the verify script. This verify script is coming from um, this verify script is coming from probably validation.cpp. Oh no, interpreter.cpp. It's coming from the script interpreter. So the same script interpreter that are interpreting the scripts of a transaction, the same function is validating the script sig and the script pub key created by this Signet transactions. And if it's verified, then it returns true. If it doesn't verify, then we return an error. Block solution is invalid.
Okay,
So
so first there's the Coinbase transaction, and from that, from the witness, I think we get the pub key, right?
yeah, no, the pub key is known, right? The pub
Okay, okay,
key
yes,
is
right.
inside the chain params.h. The
Right,
chain,
the Signet
yeah,
challenge, yeah.
the signature we will know from the Coinbase transaction of the
Oh,
Signet.
yes. Okay.
Yes,
And then from there, we'll create two more transactions, and
yes,
then we'll just do the normal verification.
normal transaction verification.
Okay,
Yes,
got it.
yes, and if it's verified, then the Signet block is valid. It's pretty simple to read through this part of the whole verification. And
Yes, yes. So yeah, initially going through the PR it was hard, but now I think I'm starting
yeah,
to
yeah,
understand.
yeah. Once it's most of the time in Bitcoin Core, you will find out like it's hard to understand the context of a particular code. Once you understand in which context this code makes sense, it will be very easy to like parse through. The C++ codes are not much complicated. What's complicated is the context, like where does this code comes into picture. Okay, so that's what transaction to spend and transaction spending is doing. Who broadcasts this transaction? We already answered it.
So it has to be those two people, right?
No. Any clue? Who broadcasts these transactions?
No, I'm confused. I have no idea.
The transactions aren't broadcasted at all, right? These transactions are only created for the verification purpose, and the
Oh, okay.
only thing you do is like script verify with this transaction. These are not real transactions at all. So these transactions are not broadcasted. So yeah, it's a tricky it's a trick question. And nobody broadcasts this transaction because these are like imaginary transactions created inside this code only for the verification purpose.
Oh, okay, okay. So this function only takes like the block, and then it
Yes.
just takes the yeah, the signature, and then okay, 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 got it.
Yes, it just
Is
takes
it
the
kind
block.
of, is it like kind of mocking the response, like mocking the transaction IDs?
Kind of like mocking the script verification function that you normally use for transaction verification,
Okay,
because
okay. So
script
is it
verification also include signature verification. We could have like directly used signature ECDSA signature verification on the public keys, right? But um, doing it this way allows, there are two advantage of doing it this way. It's like a very simple code. We don't have to like write those signature verification code anymore, because we can directly use the verify script that is already doing the signature verification for transaction. At the same time, the challenge script can be like script pub keys, right? And the signet challenge, which is defining the custom signet, then anybody can create their own script pub key, and they don't have to like worry about like verifications and stuffs. If they create the script valid script pub key and put the valid signature for that script pub key just like they do for any transaction, then they can run their own signet.
okay? Okay, that makes sense.
Right? So, yep. So that's the trick question. Nobody would broadcast this transaction. Why was get witness commitment index moved? Was anything altered? I actually like couldn't find an answer for this thing inside the PR thread, or maybe I missed it. But if anybody find out like later on, for each of this peer review club we will have a thread in our discussion channel, and I will summarize the whole thing. I'll answer the questions inside that thread, and as people are like looking into the code and looking into the concept more, feel free to ask questions and post your answers inside that thread also. That's why those threads exist. And so it's if you don't haven't noticed yet, is in the Discord channel, review club peer discussion channel. So the review club is the category and the peer discussions is the channel. The channel basically has bunch of threads. Each thread is for each review club's peer discussion. Okay. And
So,
so
so for this, I think it is being used in multiple places. No, earlier it was only used once. But I think now we are using it to get the signature from Coinbase or something.
that's a good point. Like, let's find out like where it is used. So signet.cpp is using get witness commitment index from the block. Okay. Okay, so signet.cpp is using it. Validation.cpp has been using it. Mm,
So
this
now
is
it is in .h, right? I think it earlier it was only in validation.cpp.
it was in validation.cpp and it was in validation.h. Now it was moved into source consensus validation. So there are two
Oh,
validation going on.
oh, okay,
One
okay.
is inside the consensus module, there is a validation.h, and then there is in the main folder there is the validation.cpp and validation.h. And this consensus module validation.h is actually pretty small. It's not that big. It just has definition of certain transactions. Previously it didn't had anything else. After this PR, this part of code got added, which was previously there in the main validation.h.
Oh, okay. Okay. So maybe for reusing, I guess. But then it could have been reused from the other place. I'm not sure. Yeah.
Yeah, could have been used from the other place, but probably um they don't want dependence of other module into of they don't want validation the main validation.h as a dependence on other module. I guess so. I might be wrong, but probably that was a reason. Like, this function was being used from main validation.h, and so after doing this, signet.cpp will not have dependence on the validation, right? It will only be dependent on consensus validation. So it will not be dependent on validation.h. Does anybody include validation.h? That's a good question. Huh. A lot of people include validation.h. Yeah, a lot of people guys include validation.h. Okay, so maybe that's not the reason, but probably they didn't wanted to have dependence on validation.h on this signet.cpp file, and that's why they moved it out. But so far nothing seems to be changed in terms of the logic of the function. Nothing was altered inside the function. And I actually didn't went through the double bonus and this bonus point of the question, and they seemed like more about the design of Signet and the opinions about the designers of Signet and doing certain things in certain way. And I couldn't find a clear answer of why this was there. The question was here. So inside the peer review club there was a question which wasn't answered in the PR thread, and the review club discussion also, they didn't reach up to this question. So if any one of you can find out why it was done in certain way, it's about why the Signet commitment concatenated to the witness commitment and non in its own op return. So the Signet commitment, like the signature of the Signet block is inside the Coinbase transaction, as we talked about, and it's inside the witness part of the Coinbase transaction. And yeah, so the other way was like, why put it inside the witness part of the commitment transaction? Put it in our own op return value. But could have been done, but they didn't choose to do it, and I don't know why.
So Operator has some size limits if I'm wrong, if I'm not wrong. I think since it's a multi-sig signature.
It's 80 bytes size limit. So okay, maybe. Yeah, that's a good answer. Because it has a size limit, so if it's a big multisig, then you will not be able to put it inside op return. That makes sense.
Hmm,
Right.
I can't think of anything else.
Yes, that's a good answer. Amazing. Like, we found one possible answer for this. And did you build the GUI, and how does it look different from the mainnet? I didn't build the GUI, and I haven't tried GUI in Bitcoin Core for a long time. So if any one of you guys um, tried it out, we will have these questions and try to answer in the thread. So post an answer in that thread if you try it out to build the GUI and see the difference with Signet GUI and mainnet GUI.
So this GUI is from the Qt folder, right?
Yes, the GUI is the Qt folder, and there are certain changes happening in the Qt folder. Some constants being added inside some network style CPP and network style and GUI constant.h. Yeah, some basic constants are being added in the GUI, and This is signet.h signet.cpp, not corresponding to GUI. But yeah, everything about GUI is inside the Qt folder.
Nope, I haven't tried it. Okay, I should try.
Yeah, would be fun. Okay, guys, so we are way 15 minutes over our time, but it was fun. And we are at the end of our questions. So thanks for joining in. And any other questions and comments if we drop before we drop off?
Thanks for hosting, Raj. Thanks for taking from, I guess, a basic level. And now I think I can go through the PR again and try and understand what
Yeah,
actually happened
yeah,
here.
yeah, that's the intention of the review club. It's not as intense as the actual peer review club where you go into the details of everything, but here we are aiming to have more overview, high level discussion and conceptual questions, so it actually becomes easier for people to go and look at the code and map the concept and the code together. So yep, I'm glad that it has been helpful.
Yeah, Raj, actually talking about we talked about the rectest network now. Like we
Hmm.
can make multiple nodes and then connect it to each other. Like I tried to do it and I was not able to do it. So if you have any tutorial or something, like if you already know a blog post, something written on that sort of thing,
Hmm.
then can you please send it to me, because I tried it a lot and I've been trying it since 4 days and I'm not able to do it.
What are the main problem you are facing?
Like that's the issue when I'm doing when I'm manually running the things, then the JSON RPC is not connecting even though the configurations are correct. Like when I'm manually adding everything and then connecting the nodes, then they are connected, but uh, it shows that node is added but it is not connected.
Okay. Okay. Yeah, that's an interesting problem. I actually haven't tried doing that. But in the test framework, they do it all the time inside the Python code. So uh, technically, it's not difficult to do it. It should be doable, but there might be some like particular constant, like particular parameters and configuration parameters that need to be set
Like
correctly to do it.
I think that I'm doing something wrong in the basics, so that's why I was asking.
Yeah, so maybe like one thing you can try is like, I don't know exactly of any blog post or tutorial on that, because this is something like not a lot of people try doing it. People who have requirement for like connecting two or multiple rectest node together, they are generally Bitcoin core developers, and they just go and use the Bitcoin test framework and write the Python code to do it.
Okay,
So
okay.
even I haven't like found like an use for myself of trying to do it, so I haven't tried it manually. But in Bitcoin test framework, you can see it happening all the time. Like whenever you see self dot node count more than one, that's where like two different rectest nodes are being spawned and connected together. Then you can connect and disconnect the nodes and reconnect them back again, and all these jugglings are happening. So the test framework is basically a very nice place to like learn about how to programmatically interact with multiple different Bitcoin core nodes and simulate different kind of various situations.
Okay, okay. By the way, are you using Arch Linux?
No, it's an Ubuntu.
Okay, okay.
Yeah.
Highly customized Ubuntu.
Not highly customized. The desktop framework that you seeing, it's called Regolith. It's like kind of like i3 VM, so it allows to split the screens very quickly and easily, and I find that very useful. So it allows you to do things like this, like the screen is split between this and this, and then I can very quickly do something like this, create another terminal and create another screen over here, and I don't have to like move around windows and stuff. So it's Ubuntu on top of Regolith desktop. It's called Regolith desktop. You can install it on Ubuntu, and then you will have this desktop appearance.
Okay, thanks.
So yep, thanks for joining in, guys. If no more question, and we will end our session here.